Today in this video, we are going to study about the Dapertiure, a Twitter internal load balancer. To understand this whole problem, first of all, we will understand what is the load balancer and then we will deep dive into the Twitter load balancer. First of all, we'll go back in time where there are very less users for the internet. So let's say there are only 10,000 requests per second are coming because very less people are using internet. There was not so many people were using social media at that time. So one server was easily able to handle all the things. So think of it, 10,000 requests are coming per second and this server can handle up to 50,000 requests per second. But as internet grows, let's directly jump to 2014 and 15. Now what happens? At that time, people increase. Now 70,000 requests are started coming per second. At that time, we have to understand that one server can only handle 50,000 requests. Another server can handle 50,000 requests. So what we did we just put two servers. Now when we put two servers, some of the users will send the request to this server and some users will send the request to this server. Simple. But the only problem in this is some user has to send the request to different URL. Some user will send the request to different URL. This is the only problem. And now load balancer comes in. Now what the load balancer will do, load balancer will provide one single URL to the users, one single URL. And now internally it will distribute the traffic among the servers. Okay, so the basic functionality of the load balancer is to just provide one single URL, one connection point to the users, and now internally it will distribute the traffic among the servers. Now we will understand all the four functionalities that load balancer provide. First point is prevent one server from receiving all the traffic. In our case, we have two servers running behind the load balancer. So load balancer will ensure that the traffic is evenly distributed between these two servers. Now, second is improve availability when a server fails. If one server dies, the load balancer will automatically start sending the traffic to this server. It will stop sending the request to this server because load balancer will detect that this server is not up and running. Now, allow servers to be added or removed. Basically, you can add one more server here or you can remove this server according to your need. After that, provide one stable address to the client. We have discussed it. So load balancer is just providing one single connection to the users. Now basically users are just calling one single load balancer and now load balancer is distributing the traffic behind it. Now we are going to talk about the internal load balancer and now you will understand the actual problem. Now think of it, the request come, it will go to the load balancer and now load balancer will send the request to the timeline service. And behind that load balancer, when the request reach to timeline service, let's say there are 1,000 timeline services are running. 1,000, okay? And these 1,000 timeline services has to respond back to the user. Now the think of it, one more thing, that these to generate the response in the timeline service, these timeline services has to call the tweet service. And let's say there are 100 tweet services are running. 1,000 timeline services and 100 tweet service. Of course, this is not the right number. Let me just make it 500 timeline services and 500 tweet services. Okay, so both are approximately equal now. I ask you one question now. Which timeline service, let's say the call reach to timeline service 420. Now, timeline service 420 will call which tweet service? Basically, tweet service 10, tweet service 420, tweet service 500. Which tweet service will be called? And give me an actual reason why this service we should call. Basically, if we call the, let's say, tweet service 29, then it is going to give me the fastest response. That's why we should call this tweet service. Come up with the reasoning and tell me the reason. The problem is we don't know which tweet service to call out of 500. Secondly, there is one more problem about the connections. So think of it, this timeline service can call all the 500 tweet services. It has to maintain 500 connections in the pool. Basically, it can call the 500 tweet services. It has to maintain 500 URLs and every single thing about these 500 tweet services. If I take a smaller example here, so 4 timeline services are running and 5 tweet services are running. So basically, we are dealing with 20 connections at the rate of 500 and 500, 2,500 connections. So the number is going to be huge. So basically the calculation say n cross m. So this is the problem in the internal load balancing. So we have to come up with a solution. So first solution that comes in the mind is to put a load balancer internally. So if we put a load balancer internally, think of it. These timeline services will just call this load balancer, and this load balancer will call all the behind services that are running behind it. So basically now timeline services is acting as the users and sending the request to the load balancer, and now the load balancer will take care to distribute the traffic among the tweet service. Now it's not a timeline service responsibility to figure out to call which tweet service. So now the connections will also reduce. So basically, let's say now 4 timeline services are running and 4 tweet services are running. In that case, basically we just make 8 connections. And think of it, let's say 1000 timeline services are running and 1000 tweet services are running, then only we can also make 2000 connections. And there is one more thing. We are just making the connection with the load balancer, and now the load balancer is distributing. It is just single wire, basically. It is like that. Now we reduce the connection, but there is a small problem in this whole picture. The problem is load balancer is again distributed. It is not like it's just one single server running. There are going to be multiple servers of load balancers are also running. But the problem comes is that load balancer is also becoming a network hop. When the traffic is so much, we are sending the request to the load balancer, and now load balancer is also going to take some time to send the request to the tweet service and to other services. And it is not again figuring out which is the closer one, which is the fastest one. It is just sending the request to, let's say, in the round robin fashion or in the least connection mode. And secondly, it is making a network hop. So these are the two things that you have to keep in mind. We are going to see one more thing before moving to the Dapertiure, that the first thing is full mesh. Let's say C1 is a timeline service. Okay, remember is for the whole video that C1 is a timeline service and servers are going to be the tweet service in our example, tweet service. So basically if you put a load balancer also, then also it is making a full mesh. Basically client 1 will send the request to the load balancer, and now the load balancer can send the request to server 1, server 2, server 3 and server 4. Let's say 4 servers are running behind the load balancer. Same with again client 2 will send the request and the load balancer can send the request to all the servers. Now, if we talk about the random subsets, think of it. In the random subset, what will happen? We'll make a small subset. Let's say, of course, there is going to be a load balancer between them. Then again, let me just copy and let me just paste it here for you. Now think of it again one more time. Now let's make a subset. So client 1, when a load balancer will call, but the load balancer will call only server 1 and server 2. And in the random subset, for client 2, basically for the timeline service, when the request will come, it will go to the load balancer, and now the load balancer will call the server 1, server 2, server 3 and server 4 because that is the subset. And in the client 3, what is happening? If we make a random subset, basically server 1, server 3 and server 4 it can call. Now the problem in the random subset that we noticed that sometimes what will happen, if you notice the server 1 came common for the client 1. So this server 1 can get the more load as compared to server 2 and server 4, because server 4 is just presented in these two random subsets, but server 1 is presented in all the 3 clients. So random subset is not solving the problem. Think of it, if we make a full mesh with the load balancer or without a load balancer, doesn't matter. But if we make a full mesh, it is going to be so many connections. Okay, that is the first problem. The problem is in the random subset that it is going to create a problem with the load. Server 1 will get lot of load and server 2 and server 3 will get less load as compared to server 1. So that is the problem with the random subset. We can put random subset with load balancer or without the load balancer, and we have to go without the load balancer because we don't want network hop. Now we are going to understand the requirements of the system. So first requirement is that we need fewer connections. Of course, we don't want n cross m connections. We need to go to n plus m connections somehow. Second is balanced traffic. In a random subset problem, we understand that we need a balanced traffic and we were not getting the balanced traffic. Handle server failures. Who can handle the server failure? Of course, a load balancer can handle the server failures, as we have studied in the first point. What are the functionalities of the load balancer? But the problem is, if we add a load balancer, then it will give a network hop. So what to do? Fourth is handle machine being added or removed. Of course, load balancer can do it, but we cannot put a load balancer here. And the fifth point says we are not going to put a central load balancer. These are the requirements that Twitter has to fulfill to maintain that much load. That's why we came to Dapertiure Twitter internal load balancer. Now we are going to talk about the solution. So Twitter created deterministic aperture called Dapertiure. So Dapertiure is an internal load balancing algorithm used by Twitter. It helps on Twitter service communicate with another Twitter services. And now we are going to see how Twitter built it. So first of all, I'll give you the main idea. Give every client a small but carefully selected group of server. Basically, we are going to give a subset. Basically, timeline service will get subset of tweet service, but we are going to select it. We are not going to give it randomly. We are going to give them deterministically. This is the difference. The group is not selected randomly. It is selected using a deterministic ring. That is the main point of this algorithm. So Dapertiure deterministic server subset plus power of two choices. So we have understood that deterministic server subset is going to be there, but we do not know what is this power of two choices. That comes at the end. Okay, so we'll reach there later on. So think of it, the client 1 will get this random subset, server 1, server 2 and server 3. Client 2 will get server 8, server 2 and server 3, and client 3 gets server 8, server 1 and server 3. So we are going to deep dive into this design. Okay, how we are going to achieve this? So first of all, we need to understand that there is a ring in which client 1, client 2 and client 3 are running. So basically what I'm going to do, I'll just mention it as the timeline service. Okay, and here what I'll mention is the tweet service. As many pods, as many services you want to put on this ring, you can put, doesn't matter. Secondly, what we are going to do, we are going to put this ring over each other. Now think of it, this ring is on top of this particular ring. Okay, so this is the main idea. We are going to put this ring on top of each other. Okay, and now to make you understand, I opened this ring. Okay, I opened this ring so that, think of it as a circular ring, but I opened it for the explanation. Okay, so I don't want you to be confused. So think of it that if I divide this whole line, okay, so let's say I've divided it in a simple way that I've taken a number 21 and it is easily divisible by 3. So now 0 to 7 is client 1, or let's timeline service 1. 7 to 14 is timeline service 2, and 14 to 21 is a timeline service 3, that is client 3. And right now we have 7 services for tweet service. Doesn't matter it is divisible or not, you can go with 8, you can go with 6, doesn't matter, it will make a logic. Now what we are going to do, we are going to put these numbers onto that same ring, but because we overlapped that ring. Now what is going to happen, these numbers are more, so of course 0 to 3 will server 1, 3 to 6 will server 2, 6 to 9 will server 3, server 4, 9 to 12 and so on and so forth. Now if we overlapped it, then think of it, how much area client 1 is covering and how much area the servers ones are coming, basically tweet services are coming. So for the client 1, this C1, you will notice server 1 share 3 out of 7 because the total is 7 right now. Server 2 is sharing 3 out of 7 and server 3 is sharing 1 out of 7. Basically only that much part. Okay. Now for this client 2 as well. Now 2 is from here, 3 is from here, and again from server 5, 2 is from here. So did you notice one thing? In here you will notice server 1 is getting 3 out of 7, 3 out of 7, and here 2, 3 and 2. So if they are going to be 6, or if they are going to be 5, if they are going to be 9, so distribution of the traffic is not mandatory that client 1 will call all the requests to server 3. Okay, like one service is not divided, the client 1 is going to call all the requests to server 3. Basically there is a division on the basis of the ratio. Think of it as server 1 is getting 42%, server 2 is getting 42%, and server 3 is getting 14% here. So whenever the request is going to come, it will see that where to send the request. So 42% of the time the request will go to server 1, 42% will time the request to go to server 2, and 14% of the time the request will go to server 3. We've discussed almost everything, we just did not discuss this power of two choices. So power of two choices says that we are going to pick one random 2 points. Okay, so let's say The request come from the user, it will go to the load balancer, then it will reach to the timeline service. Basically the request reached to this C2. Now why did I pick C2? Because the request is coming from the load balancer, it can go to C1 as well. Let's say it reached to C2. Now C2, what will C2 do? C2 will figure out 2 points, the power of 2. Okay, so let's say it figure out 2 points, 10 to 13. And in which range it will figure out? The range is 7 to 14. So it will figure out in the range 10 to, let's say in 7 and 14, then it figure out 10 and 13 in our example. And after that, this T2 can call server 4 and server 5. So server 4 has 9 to 12 and server 5 has 12 to 15. Okay, so now these are the two servers which our client 2 is going to call. Basically our timeline service is going to call. Now we will see, are these servers are up and running? Yes, if they both are healthy, we can call them. And now we will see which has the more chances. Now S4 has more chances to get picked for 3 out of 7 and 2 out of 7. Which service to call? So now we will go for this score. Active request and overlap size. So let's say active request, basically how many requests this server 4 is receiving right now, how many connections are right now active on this server. So let's say 6 are active and 3 is the ratio that we can call. So basically 2 and 5 out of 2, 2.5. So we will go with the least number. So basically we will just call the S4 service or S4 tweet service. This is what the Dapertiure internal Twitter load balancer is doing. So we didn't put any load balancer layer in between, and we can add more servers here, as many servers as we want. We can remove the servers from the timeline service. So automatically, think of it, if we remove the server C2 from the timeline service, what will happen? This timeline will change. The only thing is this timeline is changing, and here if we remove, again this timeline will change. And these servers has to just maintain these numbers, and if they are maintaining these numbers, so they know that which servers to call. Now we are going to understand it a little deeply. Let's think of it, this is the ring, and how we are going to handle this particular case, that let's say if we add one more service, timeline service is going to add. So I told you that we are going to change the numbers in our ring. So think of it, if it is 0, 7, 14 and 21, and if we divide it, okay, and now instead of 3 there are 4, so I can take an example of 24. So 0 to 6 is going to be C1 and C2, and after that C2 to C4 is going to be, let's say, 6 to 12, C4 to C3 is going to be 12 to 18, and C3 to C1 is again going to be 18 to 24. So this is how we are going to form a ring in this case. But when we add a C4, how we are going to inform these other services? Okay, that ring is going to be changed. Okay, so there are multiple methods by which we can do. And not only this, we have to inform this, plus we have to inform this ring as well, that the top ring is going to change. Okay, because think of it, let's say if one more service is going to add here, if I am going to add one more service here, then both the rings should know that one of the services is adding or one of the services is going to delete. We have to understand this concept. So this is going to be achievable with the help of one of the techniques that we can use. We can either use a zookeeper. Zookeeper will be going to maintain a notice that what is present in the ring. So basically zookeeper will maintain this C2 is going to contain the range between 0 to, let's say, 6, and this zookeeper will know the range between these servers as well. Basically it will know the server 1 is running right now between 0 to 3, server 2 is running between, let's say 3 to 6, and server 3 is running between, S3 is running between 6 to 9. So now zookeeper will help them to figure out which service to call. So basically zookeeper is helping C2 to call server 1 and server 2 in our case right now. Similarly, etcd that we also used in our, it is a key value database. It is a key value database that we use in Kubernetes. Third point is that if we don't want to put a zookeeper also, we don't want to put a separate service, how can we do that? Then there is the concept of broadcasting comes in. Think of it, whenever a new service is going to add, C4 is going to be added to the system. Then what we are going to do, it is going to broadcast to all the other services. Basically C4 is going to add it, then it will say that I am going to add now, please change your timelines. So right now this service will hold 1 to 7, or let's say 0 to 7. And now when the C4 comes, it will say that now in our timeline, instead of, let's say I'll make a big timeline, let's say 100, okay, 0 to 100. Okay, and let's say there are only two services right now, C1 and C2, that both contains 50 and 50. But think of it, another service comes in C3 or C4. Let's say a C3 comes in, then they will get 33, 33, 33. But now let's say C4 comes in, it will say, now please change the timeline structure, and I am going to sit at the end because I am coming at the last. So I will sit at the end. So you will get 25, 25, 25 and 20. Okay, so this is how they are going to change the structure of their timeline. And the same thing, the C4 will also involve the same thing. The C4 will also say it to all the services once. Okay, so it is a one-time activity that is going to happen. One-time broadcast to all the timeline services, and one-time broadcast to all the tweet services. So this can be one more architecture. Now, these are the three architectures that we can follow. Any of them, it is not mentioned in the vlog which one is Twitter using, but I've studied it, so I think of it that these are the three approaches that we should go with. Now, we are going to talk about the advantages and the disadvantages. So if we talk about the advantages, very few connections. Traffic is balanced between the servers. It supports failure. No central load balancer. We are not using any load balancer. Now, disadvantages. Some clients can become the hot clients, basically hot apertures, because we are sending it to some rings, some deterministic ring. But think of it, a lot of load can come to that clients, to that server, to that timeline service. Traffic burst may overload a subset, basically because we are just timeline service is just calling some subsets. And let's say on that particular timeline we get a lot of traffic, that whole subset will burst out. Membership information must stay updated. Now we talk about this broadcasting approach. Think of it, this broadcasting approach is failed. Think of it, this zookeeper was not able to update the servers for some reason. If it doesn't work out, the system will again break. Now, small deployments may need large apertures. Think of it, a new server is coming and we are going to send the load slowly to that particular server. Let's say this client 4 comes up, but let's say